All right, so both of these questions are kind of multiple V equals D over T calculation type questions, okay? Both of them do involve, however, something we talked about yesterday, which is making sure that your units match. Okay, you can't divide hours by meters per second, etc. Okay, you need to make sure that all the units for time and distance are the same. Okay, easiest way to do that is to make most of the time the units for time seconds and the units for distance meters. Most of the time, that's not always going to be true. Okay, but for both of these questions, it is. All right, so we'll first have a look at the marathon runner in the race. Okay, during the first part of the race. Okay, so during part one. Shoot. Okay, so in part one, listening please and paying attention. Weston. Okay, so in part one, okay, the person runs at a speed of 7 meters per second. All right, so notice I did not put an arrow over top of that because this is a scalar quantity, and they do that for 1.2 hours. Well, I'm going to start right away with having my time match my units here in the speed I was given. All right, so I'm going to take that 1.2 hours and multiply by 3,600 seconds. All right, so I've got 4,320 seconds. Okay, and then in part two, we've got a slower pace, okay, 6.1 meters per second, and that is over a distance of 10.6 kilometers, which I'm going to make match my units here. All right, I'm going to make that 10,600 meters. All right, so that's the information I'm given. They want me to find the average speed of the runner. Okay, if I want average speed, that means I need the total distance, not the total displacement, over the total time. All right, so let's say give them a mark for givens for right now. Okay. We're going to have to manipulate to find the distance in part one. So V equals D over T. So I'm manipulating for D. I'm going to multiply both sides by T. Okay, so D equals V times T. Okay, so give them a mark if they did that manipulation there. Okay, and then we are looking at 7 times 4,320 seconds. All right, which gives us a total distance traveled during that part of the race of 30,240 meters. All right, so I've got my distance for part one, and I've got my distance for part two, which will help me do this average speed calculation over here in just a minute, because now I'll be able to calculate the total distance traveled. Okay, so give them a mark for that as well. So we're up to 3. Okay, in part two, we don't have the time, and we need that. So we're taking V equals D over T, and we're manipulating for T. To do that, I'm going to multiply both sides by T, and then I'm going to divide both sides by V. All right, so I'll end up with T equals D over V. Give them a mark for that. Okay, that'll be 10,600 divided by 6.1. All right, so we're looking at 1,737.7 seconds. Okay, I'm going to keep all those decimals. I'm just not writing them all down. I'll keep them in the calculator. All right, so that'll be another mark there. What do you know? 5? Yeah, 5. Okay, now I've got to do this operation here. Average velocity is total distance over total time. Okay, so I'm going to take the distance from part one. That's 30,240 meters, and I'm going to add that to the 10,600 meters, okay, that happened in part two, and then I'm going to divide that by the total time, which was 1,737.7 seconds plus the 4,320 seconds. Give them a mark if they have something like that, okay, or maybe they just added those together. They've just got one number on top, one number on the bottom. Okay, that's fine. All right, so I'm going to take my 30,240 Okay, add that to 10,600. All right, so the marathon is 40.84 kilometers. And now we're going to divide that by our total time. So that's going to be our 1,737.7049. 18 plus 4,320. All right, so the average speed of the runner over the entire trip was 6.7 meters per second. Okay, that is their 7th and final mark on that one. Okay, there's no direction on that because, of course, it's speed, which is scalar, and we were given no directions in the question. All right, questions on number 1. Okay. Okay, back in the 80s, they made this terrible, terrible movie called The Cannonball Run. It was just stupid. Okay, but it was about all these different racers who were trying to win like an Arab prince's money, I think it was, and they were this cross-country race, and whoever would win would get all the money. And so, two of the contestants were this guy who had a Lamborghini Countach. Okay, it's like kind of the not so much the original, but okay. Oddly enough, Lamborghini used to make tractors before they made. Yeah, that's a weird thing. They were a tractor company, and then somehow became a performance car company. Exactly. Weird. Yes. Okay. So anyway, they had a Lamborghini Countach. That's like the first gull wing sports car, and they had that. And then there was another. Like these were kind of like your typical redneck looking kind of guys with their big jacked up 4x4 with the big loud pipes and everything, who could go anywhere they wanted because they had the monster truck tires and whatever else. Okay, so they didn't have to follow the roads. The Countach had to stay on the highway because, well, if you go over a speed bump, you rip the bottom of it out. Okay, whereas these guys could shortcut and go kind of anywhere they wanted. So what we want to figure out here is who's going to win. Okay, what determines who wins if they're not following the same path? Time. All right, so I need to figure out how long it takes each of them to get to the finish line based on whatever path they took. All right, so it's going to be essentially 2 separate v equals d over t calculations solving for t, right, Felix? Okay, so we've got for the car. Okay, the calculation for the car is, or the information for the car is that the speed is 110 meters per second and the distance it has to travel is 980 kilometers. Okay, for the truck, okay, we know that its speed is 32 meters per second and the distance it has to travel is 295 kilometers. Now, I want to right away change these kilometers into meters, which just requires me to multiply by 1,000. Okay. Now I have them in meters. There's your givens, 1 mark for that. Okay, we need to calculate the time for each one of the vehicles. So that's going to require us to take v equals d over t and solve again for t. So we're going to multiply both sides by t. We're going to divide both sides by v. So t equals d over v. All right, that's going to be, so give them a mark if they have that manipulation. For the car, that'll be 980,000 divided by 110. All right, so it's going to take the car 8,909.1 seconds. Okay, so they can have a mark for that. Okay, and then they got to do exactly the same calculation for the truck. Okay, so for the truck, we're going to have that time will equal 295,000 divided by 32 meters per second. All right, takes them 9,218.75 seconds. All right, they can have a mark for that. So now we're up to 4 marks. Okay, the 5th mark is for saying car wins, because that is, after all, what the question asked. Which one will win? You do need to indicate which one will win. The car will win because it takes less time. All right, so that quiz is out of 12. So give him a mark out of 12, let him see it, and then a nice neat pile of them right here, please.